Well, get used to it. I'm not just
Any
you're
of
going
these
into a
schools
very,
are-
very hard test on me, so I'm gonna keep pressure on. But I do need distilled water in case you wanna bring a gallon in.
Okay.
For 5 points directly infused into that last test.
What is the S?
Scan front. Scan front. You're gonna, that's all you're gonna see today,
Okay.
so I know what you wanna know that. So we'll go over the new stuff first, and then we'll talk about, or then I'll just lay out your test material and let you work on your assignment. Let's see, notice I got your assignment on the back here. What's it say? Oh, yeah. Then it says this is foundational, fundamental, and very important that you can do these. So make this assignment a priority tonight. Oh, okay. That's it. Okay. Nope. That's it. So, yeah, it's important that you can use your calculator to do pH and POH and you can transfer back and forth. You're going to use that, well, the rest of the year. Okay? Pretty easy, though, information-wise today. We're going to be talking about acids and bases. Okay?
Make water and slow water.
Yes, they do.
Hold on.
See, you're ready. You are prepared. We have 2 chapters that kind of have to do with this stuff, and it's all related to equilibrium. So that's why they're all together like this. So let's take a look, okay? There's a couple of important, really, really old people that are in the acids and bases, and I don't know how to say their names, and no one else does either because they're dead. So let's just take a look first of all, and this should be a review if you've had chemistry. Where's Alex?
Here.
There it is. We'll speak really slowly. A guy named Arrhenius, I think that was like Swedish or something, okay? Definition of acids and bases are that acids ionize or dissociate to produce, I already gave you the answers. H plus, yeah, you'll see that forever. So you'll see H plus in your sleep. So when you see H plus ions, you should think acid. Okay. When you see H plus ions after a single arrow, you should think strong acid. When you see H plus ions after a double arrow, you should think weak acids. Okay? That's where we're sort of headed. Okay. Bases. Bases ionize and dissociate or dissociate to produce OH negative ions, which are called hydroxide ions. So fill that in. So fill that in, OH negative, okay? Hydroxide. When you see a single arrow and you see OH negative on the product side, you should think strong base. And when you see a double arrow, when you see OH negative, you should think weak base. Okay. So I should try, what was that one? Meat. Go meat. What was that commercial? Hillshire Farms?
Yeah.
When I say Hillshire, you say farm. Is that what it was? So when yeah, never mind. Okay. Here comes some more Swedish people. I guess the Swedish people were really into chemistry and way back in the, I don't know, 1700s or something. Bronsted and Lowry, and I actually found the thing that you put through the O. So, yeah, Bronsted and Lowry, definition of acids and bases. I don't know, I found it under a bunch of junk. Acids, and you're going to find this is basically the same thing, but just from a slightly different perspective. Acids donate protons. That H plus looks suspiciously like a hydrogen ion. Well, it's also considered a proton because if you've got a hydrogen atom, how many protons does it have? One. How many electrons does it have? One. If we ionize this and we take the electron away, what do we have?
A proton.
That's all we got. So you could call it a proton as well as a hydrogen ion. Okay? That's why acids don't really have characteristics of hydrogen. You know, like, for example, we pick on copper. Copper metal and then copper ions. Copper ions don't have the same characteristics as copper metal, but they still share some of the metallic characteristics of copper. Well, hydrogen gas and hydrogen ions, they're like two different things, even though they're called that. It's really just a bare proton, is all it is. So that's kind of one way of looking at it. Bases accept protons, okay? So either way, let's see. According to Arrhenius, acids produce or give off H+. According to Bronsted and Lowry, they donate H+. Okay? And in either case, under Arrhenius' definition of acids and of bases, they dissociate to produce hydroxide ions. Another way of saying that is they accept protons. Because if you're OH negative and there's an H+ floating around, yeah, you like it. There's an affinity there. There's an attraction. So they're going to come together and form water. Okay? So saying that they give off hydroxide ions is another way of saying that they accept protons. Okay? The H+ or hydrogen ion is actually bonded to water, and it's called the H3O+ ion. That's got a fancy name. Is it over there? No. Anybody know?
Hydronium.
Hydronium, yeah. Hydro. So there's the water part. Neo.
Just to sound cool.
Yep, doesn't that sound cool? Okay. Now, if we include the hydronium ion all the time, we end up having to do stuff like this. Here's the dissociation of hydrochloric acid. So hydrogen chloride plus water turns into H3O plus what would be left?
CL negative.
Cl negative. Okay? That gets kind of long-winded and tedious when we could just write HCl, arrow, H plus Cl minus. So what we're really doing is just taking the water out, you know? Okay with that?
No.
Okay, but just so that you're aware of the fact that it's in there, but if we continue to carry it, it's just gonna get tedious. So they just tend to ignore the water, and they just assume that it's there. Okay? Questions so far? Anything at all? So far it's just vocabulary. Not much going on. Okay. Conjugate acid-base pairs. What's conjugate mean? There's a lot of stuff in culinary food right now where the big thing in the last 10 years has been pairing. Oh, you pair this wine with this dish, or you pair this fruit with this wine, or you pair this beer with this hot dog, you know, and all of a sudden they're just trying to get you to buy all this new stuff, you know, they call it pairings. Well, that's conjugates. That means they're tied together, okay? So you could call pairings conjugates. So in an equation, I don't know if I'm writing one, am I